All right, for the first one, what did you do in order to solve this?
Okay, graph it and use graph trace.
Graph it and use graph trace, and what did you end up when you, and then you just did graph trace for all these different values, and what did you end up with?
For the limit, I got approximately 2.8867 is what I said. Because when I rounded, we got 69.
Isn't it 0.28?
Yeah.
It was 0.28, I'm sorry.
Yeah.
Yeah.
Everyone good? Does anyone need to see? Okay, the next one, use the graph to, and you're just using the graph, you don't have to make the table to say whether the limit exists and explain why. Anthony?
Does not exist because you're jumping from -1, 5 to 5.
Okay, so when you're approaching this 5, you have that jump, so you can say jump, that's okay. That's not like that's the answer. Yes, but I also said something else too. Does anyone remember what else I said? Yeah, so what you just said. So if I'm approaching from one side, it's approaching two different numbers as I approach from the two different sides. So either one will work, but the two different numbers is the better answer. Does that make sense? Any questions on the drill? Okay, and then to go over the homework, we decided to make this civilized, and I will only allow you to ask questions up to 25 to begin with. So are there any questions on numbers 1 to the first 25? 7, 18. I didn't do 18. What does 18 say?
Pi over 2, I think. Yes. Limit of tangent of x as x plus.
Okay, so did you grab it?
I tried, yeah.
So when I graph trig, so I'm going to add a graph. I'm going to do tangent of x. Do you use the like, oh no, that's not what I want to do. So I have that, but if I hit menu, window zoom, and I go to the one that says trig, I think that helps me see a little bit better, because then I know that this is 0, then this is 2 pi. Pi over 2 is going to be about 1/4 through, so this is going to be my pi over 2 right here, this line right here. Yes. So as I approach from the left, it looks like it's going up, up, up. As I approach from the right, it's going down, down, down. So what would my limit be then? Well, so at pi over 2, and so here's pi over 2, we had a graph that went something like this. Something like that. So at pi over 2, am I approaching the same number? No. So your limit's does not exist. And your reasoning would be because as you approach from the left and as you approach from the right, you do not have the same number. Because as I approach from the left, it's going way up. As I approach from the right, it's going way down. It's not approaching a single number. Okay?
For this one, I actually had a graph in the book that shows the asymptotes. Oh. They had a graph in the book that showed the asymptotes.
Was it a pretty graph? Okay. I just wanted to point out, like, I love this doing trig when I'm in trig. I like the trig window when I'm graphing trig. Don't you? Okay. Any other questions for the trig column? 23. So this is a piecewise function. So it's asking you to find all the values for C of which the limit exists. So to find the one where the limit exists, I'm going to try to find where the limit does not exist. So if it's a piecewise function, I'm going to look at x squared. What do I know about x squared? What type of function is it? It's a parabola. Are there any breaks, jumps, or asymptotes in a parabola? No, so it's what I call a continuous function. So it's going to be a continuous function, and then I'm going to hit 2. And when I hit 2, I have a change in how my graph goes. So what I'm going to do is I'm going to take x squared, and I'm going to put 2 in there, so 2 squared, and I get a value of 4. Then I go down here to this part where I started 2, and I'm going to have 8 minus 2 times 2. So I'm going to have 8 minus 4, and I also get 4. So those two graphs meet at the same place. So what's happening? You have this parabola that equals 4 at 2. And then you have this line that technically has an open circle and does something like that. So if I'm approaching from the left, it's going to equal 4. As I'm approaching from the right, it's going to equal 4. So that limit exists at 2. Yes?
How can it eliminate the point on the plan? Because it says X.
It is a normal point on the graph.
Okay, so the limit doesn't have.
No,
Oh, okay.
no. Well, like if I wanted, look, can I finish this one and then I'll go back? Sure. Then when I hit here, so that at 4, so like here, this is 2, that's where we have the change, and at 4 we have another change, and then at, at 4 we have another change. If I put 4 in here, I'm going to have 8 minus 2 times 4, so I'm going to have 8 minus 8, which is 0, so I guess I should make that better minus 0, so I can do that. And that's going to be an open circle. And then the next part of the graph is it's equal to 4. Well, if it's just equal to 4, what is that? Horizontal line. So at 4, I go at 4, closed circle because it's equal to. So as I'm approaching 4 from the left, it looks like it's 0. As I approach 4 from the right, it looks like it's 4. Does that limit exist? No. So so the limit does not exist at 4. It exists everywhere else but 4. Does that make sense? Yes.
You can graph this.
Yes, on the calculator?
You graph that, that's.
Yes. Say it again. So the limit is what a drop approaches. So let's say I have changing colors, so change my thought process. So if I just had some function, let's say my function was f of x is equal to x squared. And I wanted you to find the limit of f of x as x approaches, let's say 3. So if I were to look at this graph, that is a parabola, and here I'm approaching 3. As I approach from the left and as I approach from the right, what number do you think I'm going to approach? Not 3. 9. So this limit is going to be 9. The only time, though there's several times, but normally the limit at a number is equal to the function at that number. The only time that doesn't happen is I think you had one on your homework. Let me see if I can find him. Where is he? Like this guy here. Like if I look here and I ask you what f of 1 is, you're going to say f of 1 is 2. Does that make sense? Because it has that solid dot at 2. Then if I ask you what the limit is x is approaching 1. From the left, it seems like it's going to be 3. From the right, it appears to be 1. Since it's approaching 2 different numbers, I'm going to say the limit does not exist. But if I ask you for the limit as x approaches 0 at this function, I'm just going to look at my graph at 0, and I'm going to say that it's about 3. So the limit exists. In fact, on this graph, the limit exists everywhere except 1, because that's where I have that jump. Even when I have 4 here, 4, when I have that open circle and I have no dot on that 4, then that's undefined because I don't have a value for f of 4 because it's an open circle. But if I ask you to find the limit as x approaches 4, from the left it appears to be 2, from the right it appears to be 2, so my limit is going to be 2. I feel like you're making it a lot harder than it has to be.
Yeah, I feel like I have too. Like, this is, like, okay, so, when you find, like, the limit, or, go back to number 23. So, it's literally just plugging what number you're trying to find, or if it's
into the function.
Okay.
So be careful though, because if I asked you what f of 4 was, f of 4 is 4. Does that make sense? But if I ask you what is the limit as x approaches 4, since I'm approaching two different numbers, that does not exist. That is the one and only time that the limit does not equal the function for this particular graph. Okay? I like the more we do, the better. Okay, are there any more questions up to the 25? Are there any questions after 25? We are not really going to learn how to use a formal definition. We are going to learn how to fudge the formal definition.
Okay.
Okay. So, see how this is saying this is L is the limit? So, limit would be my y value. Do we agree?
Yeah.
So, I want my y value to be 0.01, within 0.01. And it's asking me what do my x values have to be in order for my y value to be within 0.01. So like if I put it, so like let's do 33. If I put 2 into this equation, what do I get? I get 8. Everyone's good with the 8, so if I take 3 times 2 plus 2, I get 8. So I want to be within 0.01 of 8. So what is the highest I could be? 8.01. What's the lowest I could be?
Thank you.
So I can be 8.01, yes, and I could be 7.99. So I need this 3x plus 2 to be between those two values. So that if I solve for this x, like if I subtract 2 from both sides, this is 5.99, and this is 6.01. So if I divide both sides by 3, so divide this by 3, divide this by 3, divide this by 3, I get this. I get 1.9667. I'm asking you every time. What's 5.99 divided by 3?
1.99667.
And then if I divide this by 3, I get 2.0033. Repeating, yes?
Yep.
So this is where I'm going to stop the formal definition. And this should make sense. If my y value is within 0.01, then it should make sense that my y value has to be if my y value is within 0.01, I'm going to find out whatever the y value would be if I put it right in. I'm going to add and subtract 0.01. That's how I get this and this. I'm going to solve for the x. And when I solve for the x, that means my x value has to be between 1.99667 and 2.003. Now, the actual formal definition wants you to take it one step further and say, well, how close are these two to your original x value? So how close are they to the x value? If I subtract that 2 from here, I'm going to get negative 0.0033. If I subtract 2 from here, I'm going to get 0.0033. So that means my x value, I can add or subtract 0.0033. The block 2 being the fine negotiators that they are, we agreed that we would stop here because that makes sense to them. Does that make sense to everybody? Yes?
That's like what you want right here.
That's exactly what I want to say.
We're not trying to do plugging it in. Okay. So like,
I did plug in. Didn't we? Didn't we plug in the 2 to get the 8?
I think there was the absolute value though.
No. Because, well, the absolute value is at 0.0033, right? One's positive, one's negative. Yes. Tom? that's the epsilon. So this C is the 2, so the x minus 2, so the difference between your x value that you have and the 2 has to be between 0, which should make sense, and the 0. But the epsilon, here's the thing, nobody really uses formal definition anymore. It's kind of sad. Very sad. Not really. Next. Because that's what I was approaching. I wanted to find out how close I was to that original 2. Let's back up. I put 2 in to get that 8, yes? I wanted to be within 0.01. So then I subtracted 0.01 and added 0.01. I wanted to find out what happens to my x value when I do that. When I do that, I find out that my x value can be between 1.99667 and 2.003, and then I ask myself, which I don't really need to know anymore, how close am I to that original 2? And that's where I get the points. Can you stop here? Can you be happy with this? Yes. Do we need to do the next one? Okay, then go. I'll give you a minute. I'm going to pause. I'm going to give you a minute. Not going to stop. All right, so you substituted in 2, so you had 2 squared minus 3, and you got 1.
Correct.
So then you add and subtract the 0.01, yes? And so I end up with 1.01 and 0.99, and that's x squared minus 3, yes? You add 3, so 3.99 and 4.01. You take the square root, and you get, I don't know.
1.9975 and 2.0025.
Now, the question is, like, normally when you take the square root, you do plus or minus, right? But if I go to my graph and I'm approaching 2, I know my answer is a positive 1. Does that make sense?
Yeah.
So that's why I'm going to just stick with the positive ones and not the negative ones. And I do believe I'm within 0.0025. Oh, but I'm telling you to stop here. So forget I ever said that. Yes? The microphone's still on, and I'm now recording. Okay. Just appreciate that. We're not going to share it next time. All right, any other questions?
Go back to what you just crossed out on the instructions. Like,
On these instructions, yeah, this one just wanted you to find the limit.
so I didn't have to like try
No. And Mrs. Tessa came in and blocked too. We had a lovely discussion. She doesn't do it, so we're good. And then I moved on, and you're good with the jewelry, yes?
Sure.
Oh, I crossed out part C. See how I did that? Are we good? Okay. So now I'm good. So you will see that I have a number 7 up here that is not part of your review worksheet. Know that it is on the quiz, so you might want to copy it down. Lily, did you hear that? So you're copying this column down on the back, yes? This is board. Okay, so I'm on the website. I went to chapter 1. The review, see how at the very bottom it says chapter 1 review? That's for the review thing. So it has a worksheet. I will put the updated worksheet on there later on today. You will have a key. Hopefully I'll have all the keys. This is a video, and the video will not be updated, so whatever's there will be there. And that's all I have for you. Yeah?
Okay.
And now we're checking 1-3, because now we're going to move on to 1-3, and we want to make sure that these guys have a chance. Oh, look at that. Look at that. They're good. So we're saying goodbye to you guys. Goodbye.